What's up, guys?
Oh, you want me to sit down?
Hi, guys.
Okay, so let's get started. Remember, this is live.
This is live?
No,
Tom, don't say that.
seriously, it'll be great for parent-teacher conference.
Oh
Okay.
my god.
Yeah, let's send. Actually,
Now.
that's a bad idea.
That's
That's a bad idea. Actually, you can't see me right now, so I'm chilling.
Alright, so here's the thing. Up till now in this unit, we've kind of defined the concept of the molar mass, and we've been looking at mathematical relationships within compounds, how they're put together, how to find their formulas, what percent of each element they're made of. This is kind of like going from learning letters to words, and now we're going to learn sentences, because the first stage in really making this more interesting and useful is to understand what a balanced equation is. So I'm going to try to teach you this very methodically and make sure you understand each piece. Okay, that's why I'm going to go slow, so that you can have time to process and understand and ask questions. Otherwise, I don't want, if I overrun you, you're going to think it's harder than it is. Because you're going to feel confused at first, and your mind's going to think, oh, this is confusing. But it's not, if you follow each piece of what I'm about to do. So I'm going to start by just putting up an equation and explaining what it's saying. If you take hydrogen gas, and a long time ago in this class, we decided that certain elements are diatomic. So when I say hydrogen gas, I mean that. And when I write it in an equation, you've got to get used to seeing like state symbols. Meaning that this is saying that a hydrogen is a gas in the reaction. When I put a plus sign, what I really need to say is this is reacting with something else. And so we're going to react it with oxygen gas. And the product, what we end up making, follows an arrow, because the arrow means yields or produces or gives. And it turns out this is the reaction that shows water, and I'll keep it in the gas state, forming from its elements, hydrogen and oxygen. But if you look at this reaction, there's a problem. And I planted this seed in the first unit. You probably don't even remember. But I told you then, well, I'm just kind of putting this seed in there. Now we're going to water the seed and watch it sprout. So we had done a couple of questions specifically on water. I remember using this on the exam as well. About is matter conserved? How do you know? Can you write an equation for it? And at the time it seemed kind of hard because we hadn't really talked about it. But let's think about what's going on here. Is there a problem with the reaction that I wrote so far? Yeah.
You're missing one of the oxygen atoms.
Right, and this reminds me of a joke. So I'll tell you my joke as I kind of set up how we're going to solve
Is
it.
it the two guys in the blood?
Yes.
Oh,
No, this-
I'll have some H2O. I'll have some H2O too.
H2O2, and then
Way
he
to
died.
ruin the punchline.
Oh.
But the reason I tell this joke is because a guy walks in the bar and orders to have some H2O. Sure. His friend comes in and says, can I have some H2O2? He dies. And the reason the joke is actually relevant to this problem is watch what's about to happen. These numbers down here, we call them subscripts, right?
Those are called subscripts.
Subscripts are used to define a chemical formula, which means it tells me what the substance is. So right now, H2 is a specific structure. And if I change that, I change what it chemically is. And that's not what balancing the equation is for. In algebra, you probably have seen variables with numbers in front. There's a name for those. What do you call the numbers in front of a variable? Like when you say 2x, what is the 2 called? It's a coefficient. So, let me point this out. The meaning of the coefficients is different than the meaning of the subscripts. Subscripts tell me about the substances coming into the reaction and define their identity and behavior. Coefficients just tell me how many of each are coming in to be used or to be produced. It's a big difference, and that goes back to the joke. Because if we actually counted up all the atoms on both sides, and see I made a little list of all the elements, how many hydrogen atoms are represented so far on this side? 2. How many oxygen atoms? 2. And on the product side, how many hydrogen? And how many oxygen?
We don't.
Which is what Yasmin was saying, this is the issue, is that it seems we've lost oxygen, right? When it can't happen, that's not balanced, because that indicates matter was not conserved. Now, here's the issue. The joke about the H2O2, you might say, oh, I got this. Just put a 2 here, and it's fixed. But why can't I do that?
It's different composition.
Yeah, I've totally changed what the substance is. It's a different reaction entirely. It's not what I'm trying to do right now. I just want to fix what's already there, so things are equalized on both sides.
Is it possible to extract it from hydrogen peroxide?
To extract what?
The extra oxygen and make it?
Well, actually, it's not only possible. The reason they put it in the brown bottle and store it that way is because it decomposes naturally. It's an unstable substance. And it will break down, not monatomic oxygen, but it will break down into water and oxygen gas. And then it just becomes a bottle of water.
Wait, so if we like leave it in a cup for a few days, we can drink it?
I guess, but I don't know if they put any other things in it just to preserve it or in any way, so I wouldn't suggest that. If you're desperate for water, just go to the faucet.
That's
All right.
so far away.
So, here's my point. When we're balancing equations, the coefficients change, or can change, but the subscripts don't. Because then you're changing the meaning of the reaction itself. So all we're allowed to do is change these numbers. And we're going to use a very scientific and sophisticated method called guess and check. We just play with the numbers until it works. And for simple reactions, it's not that bad. Now watch how the numbers distribute. And I'll draw pictures to help you visualize what's going on. So right now, there's only one move I can make to start balancing this. There's a number I can put on one of those 3 lines. Coefficient I have to change. Which one has to happen to get me in the right direction?
2 was the last one.
And what do I have to put here? If I put a 2 here, I'm saying 2 water molecules. So that doesn't just affect the oxygen, does it? Because if I wrote 2 water molecules, which look like this, not only did I get my 2 oxygens, so now I'm going to kind of keep track on my list here, but what did I do to the hydrogen?
Multiply.
And how many are there now?
4.
And you can see I'm just distributing numbers. So now the hydrogens become 4. So I tried to fix one, but I messed up the other one. But, see,
Would be the hydrogen that you said?
this one,
Yeah.
if I put a 2 here, now instead of just having one of these little units, I'm saying there should be 2 of them.
And then 1 for the next one.
And this, we don't have to write the 1 technically because the symbol represents 1, but I'll put it for now because there's a line here, right? Just to emphasize it. But once this happens, you can see that even though the structures are different before and after, the atoms are the same amount in kind. That's what balancing means. Now, once we've shown that all the numbers are equal, the equation is balanced. What does it really mean? Why is it important? Because now I have the recipe, the actual correct ratios in which these combine and how much of the product can form. It's not the amount I'm mixing, it's just the recipe. And we're going to learn that we can take these recipes and scale them up and down. We can basically use the ratios to calculate any amount of reactant or product that we need to use or make. And this is where quantitative chemistry really is based on. Any questions so far about what or how or why what I just did? And let me not ask, are there any questions? Are there any confusions? Is there anything, whether it's a number, an idea, a symbol, that doesn't have meaning to you right now on the board? Yeah,
What is the G meaning?
gas, just the state of it. Go ahead.
Don't the subscripts and the coefficients kind of mean the same thing though? Like aren't you multiplying element with like the subscripts too?
I see what you're saying, but let me show you what's different, right? Is there a difference between saying this and saying this?
I mean,
Yes.
Those people.
where people are like, yeah.
So this in the language of chemistry, instead of representing it this way, would be represented this way.
Why would they be combined?
So it just means that they're combined.
Yes,
Oh, okay.
but that's a different
Whereas
thing.
the coefficients
can't you
being
break
like
it
two
down, though?
singular ones by itself.
Yes.
Okay.
So that's why I drew it this way here. But I thought this might visually help you see the language of chemistry. Here, this I have two separate people. Here I have one object that is a union of two people as one thing. Here I have two hydrogens that are connected as one molecule. But this says I have two instances of that.
Okay.
Good? Anything else? Yeah.
Isn't H2O liquid and not gas?
Depends. It can be either. So if we do a small amount of this reaction, the amount of water that's produced is so small and spread out, there's not enough of it to accumulate to form liquid droplets. But yeah, you're right, it would be. Another, I mean, it's not invalid, depending on how much reaction I do, to call this L for liquid exponent. You're right. Anything else? Okay, so let's try another one and see if it's any different or if we're basically just doing the same thing. And eventually, I'm going to give you some tips on how to solve more complex ones, but the method is the same. The underlying reasoning is always the same. All right, so the new reaction I want to do is another, what's known as combination reaction between two different elements. This time, let's mix nitrogen gas with hydrogen gas and produce our friend ammonia. So again, and for some of these, once you get the hang of this, you're not going to have to write out the list and count everything. You'll probably be able to do them on the fly. But right now I see again a list of two elements. There's nitrogen on both sides, and there's hydrogen on both sides. How many nitrogen atoms are represented on the left? How many hydrogen?
Two.
How many nitrogen are represented on the right? How many hydrogen are represented on the right? Okay. So now we have two problems to fix. Is there necessarily only one way to start? No. So let's just try. Yeah.
When you put a 3 next to the hydrogen, a 1 next to the nitrogen, and then it would be a 2 next to the NH.
Wow, you got it all just like that. Very nice.
Wow.
So just so we can kind of be more methodical to see the process I think you went through, you saw that one immediately quick move to fix the nitrogen would be to put the 2 here. Right? You have no choice, do you? There's no other place to get nitrogen on this side. So at least you have to put a 2 here. Does that make sense why I put a 2 there? Because now if there's a second ammonia molecule, there's a total of 2 nitrogens. But what does that do to the hydrogen that's part of the molecule? Now you'll notice, I just want to point something out. Let's just pretend there was another substance here. Would this 2 affect this? No, just like in algebra, the coefficient is only with what's immediately attached to it. Now, once you see that, the next move should be a lot more clear, because now that we have 6 hydrogen on the right, we need to get 6 hydrogen on the left. What number does that?
3.
And that's exactly what Zaid said. And again, we can put the 1 just for the sake of filling the line, but typically you don't have to put the 1. What do you think? That's the second example. The 2 points define a line yet? Like,
Yeah.
do you get it?
I get
So
it.
let me put some up. Let me put one at a time for you to try now. Yeah.
Are you just trying to make them even on both sides?
Yes.
Okay.
Balance.
Yeah.
Exactly.
So basically
Yeah.
geometry, or not geometry,
No.
algebra.
It's a rudimentary algebraic application. Yes.
X plus 1 equals 3 is X.
Well, not even that, really. I mean, kind of, maybe in a way. I get what you're
Add
saying.
something to a number and then try to use one.
All right, let's try one that has more than just 2 things on one side. So far I did 2 examples where there was only 1 product. Let's look at another industrially important reaction, the combustion of methane. Methane gas is one of the, it's what we call natural gas. It's the stuff you burn at your house, and it's also the stuff that comes out your backside when you eat meat. That's a true story.
Wait, what? Oh.
It's spark gas.
Oh. Isn't it like flammable?
Yes. Yes. Well, that's why I'm showing a combustion reactor. Combustion always has the same products, interestingly. We talk more about this tomorrow. But anytime carbon and hydrogen together react with oxygen, you always get two basic products. Carbon dioxide and water. I'll keep the water as a vapor again, gas.
So whenever there's a G, that means gas.
Gas. If it's an L, it's a liquid, an S is solid, and if I dissolve something in water, we use an AQ, which means aqueous. Just dissolve it. It doesn't affect what we're balancing, it's just I
I
want
just
to
want to
get
know
you.
like what if you.
Exactly. I want you to be familiar. So, why don't you all try this one yourselves? And that way I can see what Cho problem might be. What Cho problem might be.
Oh, that's a good one.
Thank you. You're done? Why don't you compare with each other? You agree?
I got
Yeah, that's right.
I got 1, 2, 1, 2. Yeah?
Nadeo. Now, see if maybe if you're not clear on something you can ask. It's so important. One of the most important things you can do is learn how to ask a question. In fact, there's a Nobel Prize winner. I can't remember his name now, but he was from like, he won the Nobel Prize like 30 or 40 years ago, maybe more. And he was inspired by his grandfather, who would never asked him, what did you learn in school today? He would always ask him, did you ask a good question today? And that really kind of got the guy into a mindset of how important it is to ask questions.
No question is a bad question.
That's true.
I'm sure.
Well,
there's.
there is one kind of bad question, the kind that isn't asked.
Exactly. Well, that's not a question though.
Wasn't it? If you have a question and don't ask it, it's a wasted opportunity.
Yeah, wasted opportunity. Not
What about a wasted time question?
Well, there's that. That's true. I mean, you're right, but that's kind of like,
I like his water wet.
oh gosh, don't
Oh,
say
yeah,
that.
this would be 2.
Did we get the answer, or do you want to see it work through?
Yes.
We got the answer. I think we're good.
It's 1, 2,
1, 2.
1, 2. Is there anyone that needs that explained? Go through it? Okay. So, watch this. This is one of my pro tips for you.
Oh,
How many elements are in this one?
5.
No,
Two.
not atoms.
2.
2 elements. So if I put a number here, don't I change 2 things?
Yeah.
But this one only has
No.
1 element. So always leave the simplest for last because you're messing up the fewest things. So I wouldn't have started by trying to balance oxygen in this case because it's in a lot of places. I'd leave it for last. But if we start with our count, there's a carbon and 4 hydrogen and 2 oxygen on this side. And again, if you don't see how I'm getting those numbers, just ask. On this side, it's 1 carbon, 2 hydrogen, and a total of 3 oxygen, right? Because there's 2 separate sources. Now, from this position, I have to ask myself, self, where should I begin? Well, the carbon's done. The oxygen I'm going to leave for last. It seems like the hydrogen would be the way to go.
Well,
How do I fix the hydrogen? Where and what number?
leave it as 1. Leave it.
No, the hydrogen.
Divide it by 2.
We don't typically divide, although there's a trick to that I'm going to teach you tomorrow. Yeah.
Added 2 to the hydrogen off the water.
So the water? So if I put a 2 here, I get 4. Now, careful when you recount. There's still these 2 oxygen, and now there's 2 more. So the oxygen has now become 4. Well, the carbon's still fine. I just need to finish the oxygen. And it seems pretty obvious at this point that it has to go here, and it has to be a 2, since 2 times 2 makes 4. And when I check my list, everything's balanced. So this is the ratio in which these combine and the products are formed. The equation is balanced. Now, I was gonna give this whole assignment today, but I decided it was smarter to pace ourselves, so I'm gonna give you this paper.
Good
I-
idea.
Thank you. I just want you to do the first 5. They're kind of what I call the level 1 problems. You can probably finish them in 5 minutes, if you know what's going on.
minutes?
Am I getting?
Well, we only have 4 minutes, so.
Oh. This is something completely different from the last 2 days, right?
Essentially, yeah. We're gonna connect the dots between them, but right now, this is all we did. Can you actually stop it at this point, because we're done?
Yeah.
Hit the same button. It was recording, right?
Yeah, it was.
Yeah.
Thank
Hi,
you.
guys.